problems from section 3.5. Start with problem number 1. In problem number 1, we're told that y is equal to 1 plus x minus cosine of x, and we're asked to find dy dx. If we take the derivative of both sides of our equation, the derivative of y with respect to x is dy dx. On the other side, the derivative of 1 with respect to x is 0. The derivative of x with respect to x is 1. And the derivative of, let's take a look at this as the opposite of the derivative of cosine. So we get 1 minus, and the derivative of cosine is negative sine, thus giving us the answer 1 plus sine, that dy dx is equal to 1 plus sine. Okay. Problem number 2. Y is equal to 2 sine of x minus tangent. Again, let's think about taking the derivative with respect to x of both sides. Dy dx is the result of the left-hand side derivative. The right-hand side derivative could be thought of as 2 times the derivative of sine x minus the derivative of tangent x. This is 2. The derivative of sine is cosine minus the derivative of tangent, which is secant squared. Problem number 3. Y is equal to 1 over x plus 5 sine of x. Let's take the derivative of both sides of that equation. Again, it's dy dx, not dx dy. Get that notation perfect. Dx on this side. Let's think of this again using the addition subtraction rule and the constant multiplier rule. We've done the 1 over x problem so many times. I've memorized the solution. It's negative 1 over x squared plus 5 times the derivative of sine, which is negative cosine, positive cosine, giving us the answer of negative 1 over x squared plus 5 cosine. And sometimes the books like to have the negative stuff at the end, so you might see that answer in the book instead. It's number 3. Number 4. Is y is equal to x secant x. Let's take the derivative of both sides of that equation. Bad notation again. Let's get that straightened out. Now, at this point, we should say, the right-hand side is the result of a product. So what we really have is a product rule. First times the derivative of the second plus the second times the derivative of the first, giving us x times the derivative of secant, which is secant x tangent x, plus secant x times the derivative of x, which is 1. Now, in this case, it's probably worth our while to take a look at the other part of the instruction, which is we confirm this graphically. And so I'm going to switch over to my calculator, and I am going to confirm graphically that this derivative, this function has this particular derivative. So let's get the calculator started. Let's get out of large screen mode. Let's bring our calculator over to the side here. Oops. Try that one more time. Be more careful. There we go. All right. So what I want to do is in my calculator grapher, I am going to put in what my derivative function, or what I believe the derivative function is, x multiplied by secant. Now I don't have a secant button, so I'm going to go 1 divided by cosine of x. And then multiply that by tangent. I do have a tangent button. And at the end, I'm going to add that to 1 divided by cosine, which is my secant function. So there's my, there's what I believe is the derivative function. And then I'm going to use nderiv to draw out the derivative. And what I'm going to do is I'm going to take the derivative with respect to x of y1, and I want to draw it out as x varies with x. Terrible notation, but that's the calculator for you. Let's do zoom 7 because it's a trig. And there we have the drawing of what I believe is the derivative function. And I made a mistake. I'm going to stop the drawing for a second. I made a mistake by not making the second drawing with a thick line. So we can't tell whether this function is the same as the other one, or is it just off the screen. So let's do that one more time. Here again is what I think the derivative is. And then the second set of lines is going to be thicker, and it's going to be what the nderiv function gets as it does the numeric derivatives. And I've got a mistake here. I've got something that isn't quite right. Now, this is way off. Holy moly, where did I screw up? Let's take a look. I think my math is okay. I'm going to stop the drawing. Oh, because I don't want y1 there. I want my original function there. I want x, let me do x secant x, which is going to be the equivalent of dividing by cosine. That's what I want. Let's take a look and see if I got the right answer. There we go. Now you can see that the nderiv function is tracing right above what I thought the derivative was. I have indeed confirmed graphically that my answer is correct. All right, so let me put the calculator away, and let's go on to problem number 5. In problem number 5, we have y is equal to 4 minus x squared times sine of x. Again, we'll take the derivative of both sides with respect to x. left-hand side is going to be dy dx as requested. The other side, again, being probably more thorough than I need to be, but on these initial problems, it's easier and better to be more thorough. Derivative of 4 with respect to x is 0. That's the constant. Minus. This is going to be the product rule. It's going to be first times the derivative of the second plus the second times the derivative of the first. So you end up with negative of x squared, the derivative of sine is cosine, plus sine of x times the derivative of x, which is 1, giving me a total of negative sine minus x squared cosine x. And that's problem number 5. Number 6, y is equal to 3x plus tan x. Taking the derivative with respect to x of both sides. We're going to end up with dy dx on this side. We're going to get the derivative with respect to x of 3x plus the derivative with respect to x of tangent. The derivative of 3x is 3. The derivative of tangent is secant squared. And that's problem number 6. Let's take a look at problem number 7. 7, y is equal to 4 over cosine x. Let's take the derivative with respect to x of both sides. Our left-hand side, as usual, dy dx. Our right-hand side is going to require the quotient rule. Bottom times the derivative of the top minus the top times the derivative of the bottom all over the bottom squared. Cosine of x, the derivative of 4 is 0, so that part's going to go away. Minus 4, the derivative of cosine is negative sine, and that's all over cosine squared. Cleaning that up, we end up with 4 sine x over cosine squared x. If we wanted to be tricky, and the authors often want to do that, they may break this up into 2 pieces and say, oh, that sine over cosine is tangent, and 1 over cosine is secant. Now, what's not surprising there is that that comes out considering the fact that this problem could have been rewritten as 4 times secant x. And in an alternate version of this, we've got a constant multiplier times the derivative of secant x, and that of course is 4 secant tangent, the same answer that we got going the long way. Number 8, y is equal to x over 1 plus cotangent x, cosine x. Taking the derivative of both sides. Get dy dx is equal to bottom times the derivative of the top minus the top times the derivative of the bottom, and that's all over the bottom squared. 1 plus cosine x, the derivative of x is 1. X times, the derivative of 1 is 0, but the derivative of cosine is negative sine. And this is all over cosine, 1 plus cosine x squared. So 1 plus cosine, distributing this negative through, and we end up getting plus x sine x all over 1 plus cosine x quantity squared. This might be also a good one to confirm using the calculator. So let's do that. So I'm going to switch back over to here. Let's clear out the old one. We said that the answer is 1 plus cosine of x plus x sine of x, and close parenthesis there. Let me just make sure that I open, okay, I started with a parenthesis, I ended with a parenthesis, and let's divide that all by 1 plus cosine of x squared. In here, we're going to put our original function, which was x divided by, second insert paren 1 plus cosine of x. That looks right. Let's see if it graphs right. There's the function I think is the derivative. Oh, something's wrong. Let's stop that. Now, is it my graphing, my use of the grapher that's wrong? Or is it something else? I'm going to redo this, and I'm going to use the new technology. Well, I'm going to write this function using the fraction form. This is my derivative function, so I'll put 1 plus cosine of x plus x sine of x. That should make it a little bit more readable, and that's all over quantity 1 plus cosine of x quantity squared. And in this one, I'm going to clear out the inside there, and I'll also put in my original function x, whoops, clear that out again. Go into fraction mode, and I get x divided by 1 plus cosine of x. Let's graph that. Let's see if that makes a difference. So there's what I think the derivative function looks like. And there's what the end derivative gives as what the derivative function looks like, and we get overlap. So we must have gotten that right. I just must have keyed it in wrong. All right. Let's put the calculator away. And let's get on to problem number 9. Problem number 9. I've got y is equal to cotangent of x over 1 plus cotangent of x. Let's take the derivative of both sides. Let's use our best notation. dy dx is the result of the left-hand side. The right-hand side will be a quotient rule. Bottom times the derivative of the top minus the top times the derivative of the bottom. And that's all over the bottom squared. So 1 plus cotangent x. Now the derivative of cotangent is negative cosecant squared minus cotangent of x times the derivative of 1 plus cotangent. The derivative of 1 is 0, but the derivative of cotangent is cosecant squared again. And this is all over 1 plus cotangent x squared. Distributing, we get negative cosecant squared minus cosecant squared x cotangent x minus cosecant squared x cotangent x all over 1 plus cotangent x, quantity squared. And it looks like I messed up. Looks like when I took the derivative of cotangent, I left off that negative sign, which makes that's a positive, and those two terms go away. So I end up with negative cosecant squared all over 1 plus cotangent quantity squared. And again, this one we'll do on the calculator to confirm. All right. Too many things going on. Here's my solution. Here's my calculator. All right. Let's put in what I think was the original function. Okay, cotangent. Now, we don't have a cotangent button, so what I can put in is what cotangent is, which is 1 divided by tangent. So there's cotangent on the top, and then 1 plus what cotangent is, which is 1 divided by tangent. Well, that's my original function. I don't want that there. What I want here is my derivative, which is clear. What I want is, let's get in fraction form again. I want negative cosecant. Negative, but cosecant is 1 divided by sine. So there's my negative cosecant on top. And on the bottom, I have 1 plus cotangent, which is 1 divided by tangent. Close that off, and let's square that. So there's what I think the derivative function looks like. Now down here, I want to put in my original function. Let's clear that out. 1 divided by tangent for my cotangent. And on the bottom, 1 plus 1 divided by tangent for my bottom. And that should do it. Let's go ahead and graph it, and let's see if indeed we get the confirmation graph. So there's what I think the derivative function looks like. And that is not the same function. Well, nope. So let's see if we can figure out where we made the error. Now, there's 2 possibilities. Again, possibilities are that I either put it in the graphing software wrong, or that I made an algebraic error or a calculus error. Cosecant squared. Okay, my derivative matches my grapher. My original function matches. So there must be an error in what I did to derive the function. Bottom times the derivative of the top minus the top times the derivative of the bottom. Derivative of cotangent is negative cosecant squared. That part's right. Derivative of 1 plus cotangent is negative cosecant squared. That's right. This gives me a negative cosecant squared. Oh, those look good. Oh, I see the problem. The problem is I didn't enter it correctly. I missed that cosecant squared there. So what I need is to, in my derivative function, I need to insert a parenthesis there, and I need to square my answer, at least the cosecant part of that answer. Now let's take a look and see if I got it right. There's the function I believe is the derivative function. That makes sense. It should be negative everywhere because cosecant squared. And there's my deriv tracing over exactly. So it looks like problem number 9 is right. All right, let's take a look at problem number 10. Okay, in problem number 10, y is given as cosine of x over 1 plus sine of x. Let's take the derivative with respect to x at both sides. Let's write it well. I'll get dy dx on my left-hand side. I'll use the quotient rule for the right-hand side. Bottom times the derivative of the top minus the top times the derivative of the bottom all over the bottom squared. So it'll give me 1 plus sine x. The derivative of cosine is negative sine minus cosine. The derivative of 1 plus sine is cosine. And on the bottom, I get 1 plus sine x quantity squared. Cleaning that up, negative sine, distributing these two, so negative sine minus sine squared minus cosine squared all over 1 plus sine x squared. Let's take a negative 1 out of these two terms, and I get sine squared x plus cosine squared x all over 1 plus sine squared sine x quantity squared. That, of course, is our Pythagorean identity. So I end up with negative sine x minus 1 over 1 plus sine of x quantity squared. Now, if we factor a 1 out of this term, we end up with negative 1 plus sine x over 1 plus sine x quantity squared, and that, of course, ends up being negative 1 over 1 plus sine x. There we go. Let's check this one graphically. All right. derivative function first. I believe it is, this over here, let's see what we're doing. Let's clear that out. Negative 1 over, let's clear that bottom out. 1 plus sine of x. And then in here, let's put in our original function, clear that, which was cosine of x. And in the bottom, 1 plus sine of x. Maybe we can get this one right the first time. Here's what we think the derivative function is in thin lines, and then the end deriv tracing right over the top of it. Great. Excellent. All right.